Hi, Math 8. Hope you guys are doing well. It's time for assignment number 8. I didn't write that down anywhere, but just so you know where we're at, this is assignment number 8. And assignment number 8 is a quiz. It's the second quiz that you've done since we've started this online thing. So, quiz number 2. What will it be on? It'll be on probability, since that's what we've been doing. So basically on the quiz, I'll show it to you in a minute here. There's going to be one tree diagram, and then there's a couple questions on independent and dependent probability. It's not that long. There's a couple tough ones, but I think a lot of it you'll be able to go through pretty quick. So I did promise you I would explain to you the difference between independent and dependent, or specifically give you an example of dependent probability question, because there was none of those on your review. So let's do one independent and one dependent, and it depends on whether there's replacement or not. So there's 6 marbles placed in a bag. Oh, a bag, fantastic! You know how excited I am about drawing bags. And inside that thing we have 2 red. So there's one. Oh, I don't want it to stick together this time. So 2. I'm hoping now that they'll move separately. Do they? Yes. Okay, good. White. Why do I keep doing this to myself? Didn't I learn from my mistakes last time? So there's one white. Pause, pause, and here's my other white, so that those will be treated differently. Then we have a black. There's black and yellow. If you don't understand what I'm doing with all the pause and everything, don't worry about it. Just know that here is the bag with the marbles. We're ready to go. Okay, so we're going to do the same question. What's the probability of getting red and then red again and then white and then black? We're going to do it twice, once with replacement and once without replacement. So when you do with replacement, this is independent, because the first pick doesn't impact the probability of the second pick and doesn't impact the probability of the third pick and the fourth, etc. But the second example, this is dependent, because once you've picked out a dependent, boy, that's bad. Once you've picked out a marble, if you don't put it back in, that's going to impact the probability for the remaining picks, because you're down 1 marble. You've lost a marble there. All right. Okay, so let's do both of these. First one is probability of getting a red. Okay, well, how many are there in here? 6. We said that here. Let's make sure. 1, 2, 3, 4, 5, 6. Yes, total number of outcomes is 6. How many of them are favorable for the first outcome? That'd be a red. Well, there's 2 red. So we have 2 out of 6, which we could put in lowest terms, but I'm not going to do that today. Okay, so not yet anyway. So now what we do is we pick that one of those red ones out. There it is. But we're replacing it, right? This question is a replacement question. So we just go ahead and put that red one right back in, and away we go. We do the next one. What's the probability of getting red? Well, guess what? It's going to be exactly the same because we replaced it. If you don't believe me, let's count them up. 1, 2, 3, 4, 5, 6. So the total outcomes is 6. How many of them are favorable? How many of them are red? 2 of them. So again, it's 2 out of 6. And we pick one of the red ones out. Doesn't matter which one. I'll pick this one. And we put it back in again. So we're back to the starting place again. This time we want to know what's the probability of getting white. Okay, white. Well, how many total are there? 1, 2, 3, 4, 5, 6. So it's still out of 6. It's always going to be out of 6 if you replace every time. And how many are favorable? How many are white? 2 out of 6 again. Okay, good. So we take one of our whites out and we put it back in. It's kind of silly to be showing you this, but hopefully it makes sense. And finally, we want to get a black. How many total are there? 6. There's always 6 if we replace. How many are favorable? How many are black? Just 1. Okay, there's all our probabilities. What do we do with all those? We multiply them. Great. Now, here's where I probably should have put in those terms, because for all these 2 over 6, we could change it to 1 over 3 times 2 over 6 is 1 over 3 times 2 over 6 is 1 over 3 times, and our 1 over 6 is already in lowest terms. So we have 1 times 1 times 1 times 1 is 1, and then 3 times 3 times 3 times 6. Well, 3 times 3 is 9, 3 times 6 is 18, and 9 times 18, well, 10 times 18 is 180, take away 18 is 162. So I have my answers in lowest terms. I would love it if you would put your answers in lowest terms on the quiz. Okay, please try to do that. Okay, now we're going to do the same question, but this time we're going to do it without replacement. So this is dependent probability. So we want to start by picking out a red. Guess what? It's going to be the same as here, right? There's 6 total in here. So 6. How many of them are favorable? How many of them are red? 2. So just like we did before. But this time, when I remove one of those red ones, I'm not putting it back. So this is going to change things. Now when we go to the second marble, another red one, what do we have? Well, there's not 6 left in there anymore. There's only 5 left in there. And how many of them are favorable? Just one, that red one. Let's get rid of that red one. And we go on to the next thing. We want to get a white one. How many total outcomes are there left? There's 4 total outcomes left. How many of them are favorable? There's 2 whites, so there's 2 favorable outcomes. Get rid of one of the whites. And we go on to our last one. Black. How many total are there? 3. How many favorable ones are there? There's 1 black there. So our top number will be 1. And you could definitely move the black out if you want, but we're done the question, so it's kind of pointless. What do we do with all those fractions? We are going to multiply them together again. All right, this time I'm going to not rewrite them like I did up here. I'm going to ninja slice. So there's all sorts of things you could do. I see the 2 and the 6. I could ninja slice those and make them 1 and 3. The 2 and the 4 could become 1 and 2. Well, now we have 1s all on the top, so we're definitely done. 1 times 1 times 1 times 1 is 1. 3 times 5 is 15, and 2 times 3 is 6. 15 times 6 is 90. So that's your final answer. So, is that surprising to you? It's more likely to do it if you don't put them back in than if you do put them back in. I think that kind of makes sense, right? Because if you still have a lot of balls in there, you have more different scenarios available to you. So, neither one of them is very likely, but this one is a little bit more likely if you do it without replacement, if you leave them out when you pull them out. All right, that's it. So your assignment number 8 is quiz number 2, and it is due next Monday, which is what, May 11th at 3 p.m. Want a quick look at the quiz now? Of course you do. Here it is. So we have a tree diagram up here for number 1. Then for B, you use your tree diagram to figure out a probability. Remember, look at all the pathways and everything. Then we have a question with balls in a bag sort of thing, but you're only picking out one ball. One ball here, one ball there, one ball there. So that's like when we first did probability. And then for number 3, you've got a drawer with socks, and you're pulling out more than one sock, either 2 socks here, 2 socks here, 3 socks here, 4 socks here, and this is where you're going to do what we were just doing. Now, it's important to realize that you have with replacement here, without replacement there, without replacement there, without replacement there. So please be careful when you're, doing these questions. All right, everyone, you can do corrections on these. So if you make any mistakes, you send them to me. I'll mark them, give them back to you. You can do some corrections. Take care. Shouldn't take you too long, I hope. And that'll be it for probability. We'll move on to the surface area and volume and all that kind of stuff next week. Bye, everyone.